right, so, good afternoon. Tuesday, 15th. Today we're going to graph the other four trig functions. Yeah. So far we've graphed sines and cosines. Today we're going to graph the other four. Tangent, cotangent, cosecant, secant. Yeah. We'll do that today. Then tomorrow we'll talk about inverse functions. So we'll talk first about inverse sine tomorrow. And then Thursday will be more about inverse cosine and inverse tangent. And then Friday, this week Friday, in through the weekend, basically, we have a very short formative. Like it's going to be a 6-question, multiple choice formative. Should take you less than 5 minutes, kind of a deal. Okay. And Mrs. Hill has posted a video for you to watch on the content page. Reach out this week. And I think that video is like, it's under 10 minutes. I think. So we're talking 15 minutes of work over the weekend. So not extremely a lot to do. Okay? So we got that going for us, which is nice. Okay? So then, before we get going today on our graph, I want to talk just a little bit about fractional logic. Okay? So if I have a fraction, A over B, that's my fraction. Okay? When is that fraction equal to 0? And anybody at homers or in-personers, you guys can jump in at any point in time to answer these questions. When is that fraction equal to 0? Okay. When A is equal to 0. Okay. When is that fraction equal to 1? When A is equal to B. Okay, let's pick it up a notch. When is that fraction equal to negative? Curveball. So when they're opposite, so what you're going to say? Love it. Yep. If A and B are opposite. Okay. When is that fraction undefined? Everybody understand those four? Fractional logic. Okay. Okay. Let's do this. Graph. Okay. So we want to graph y equals tangent of x on the interval -2 pi positive. Okay. So, what I would like you to do is I'd like you to draw a crosshairs, if you will, the Cartesian coordinate system, and stretch it out. Okay? Don't try and just draw it a little teeny tiny. because then you'll miss out on all the details. Draw it big. Draw it almost all the way across your nose, if you will. And then while we're at it, we can set up our horizontal axes. Or we can set up the spacing. So as you sitting at home, you're missing out on my highly scientific spacing. If you're a fan of Texas, it's one. Give you a minute to get that copy done. So, my question to everyone is, well, first off, what is tangent? Either on the unit circle or in general. What is tangent? You got it. Tell me which one. Okay. One of the two. It's y over x. Yeah? But that's on the unit circle. This is okay because we'll be using our unit circle here in a minute. Okay? In general, though, what is tangent? Other than soar, other than opposite over adjacent. What's another way of saying tangent? On the unit circle, what's what? Exactly. Tangent is also sine of x over cosine. Okay? So, my question to you now is this. When is tangent zero? When is tangent equal to zero? Based off of our fractional logic. If sine of x equals zero. So tangent is zero if sine is zero, and we get that from this, from that logic that we just did. A fraction is equal to zero only if the numerator is zero. Okay? So tangent is sine over cosine. So tangent is zero only if sine is zero. On my unit circle, where is sine equal to zero? Sine equal to zero. First left. At zero, at pi, at 2 pi, right? So that's the positive one. Now let's go negative. Negative pi and pi. Okay? So tangent is 0, if sine is 0, and that happens at x equals 0, pi, 2 pi, negative pi, and negative 2 pi in the interval that I'm dealing with. So on my graph, tangent is going to be 0 there, 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 and there. With me so far? Okay. Alright. Onliners, you're going to have to unmute yourself and say, Lynn, have a break, we're going too fast for you. Tangent of x is equal to 1. Guess what? Where is tangent, or what scenario from our fraction logic would make tangent equal to 1? So sine equals cosine? Okay. So where on my unit circle is sine equal to cosine? Pi over 4? Pi over 4. Okay. Those are the positives, right? That's this one and that one. Right? Now let's get the negatives. That one is negative 3 pi. This one is negative 7 pi. Right? Because if I am dealing with the fourths, the pi over 4s, right? It takes 8 of them to get all the way around the circle. The whole circle is 2 pi. So that's 8 pi over 4 to get all the way around. If I use 5 of them to get to here, that means I got 3 of them to go yet. That's why it's negative 3 pi. If I use 1 of them to get to here, that means I've got 7 of them to get all the way back around. Okay? So this would tell me that tangent is equal to 1 at x equals pi over 4, 5 pi over 4, negative 3 pi over 4, negative 7 pi over 4. So that's where tangent is equal to 1. That's here. Here. There. There. When will tangent be negative 1? sine and cosine the same, just opposite. Three pi over 4. And, Mr. Chan. Oh, I thought you said 7 pi over 4 before. That's what he's telling you. He gave it to you, man. It's 7 pi over 4. Right? The negatives of those would be negative pi over 4 and negative 5 pi over 4. So that's where denominator is equal to 0. Okay? Where on the unit circle is cosine equal to 0? Pi over 2. Pi over 2 are the positive. The negative pi over 2 would be the bottom, and negative 3 pi over 2 would be the top. Now, it's undefined there, which means that our function can't go through that point. Anywhere that there's an undefined, or I can say this is the proper English. These are vertical axes. So those give us vertical asymptotes because their function is undefined there. We can't cross over a vertical asymptote. So remember that vertical asymptotes, or any asymptote vector, goes onto your graph using a dashed line. That allows us then to draw in our function, our tangent function. Our tangent function is going to be like heat blowing in the wind. That was bad. That was bad. Didn't even wave that one. Oh man. And that is the graph of tangent of x. Alright, so with that being said, clear this one off. And let's go on to secant of x. Same process, same logic. Okay? But first off, we should figure out what secant is, because we're going to want to graph this on the interval, same interval. So we're going to graph that on the same interval. So what is secant? Either on the unit circle or off the unit circle. It's 1 over cosine, yep. Or on the unit circle, that would be 1 over x. Right? Okay? So then, we can set up our axes. Love it. Here we go. First one was, when is the secant of x equal to 0? When is secant equal to 0? No. No. Say it. Never. It's never equal to 0. Because why? Let's go back to our fractional logic. Our fractional logic said that this fraction is equal to 0 if a is equal to 0, right? If our numerator is equal to 0. What's the numerator? 1. Can 1 ever be 0? That's my one. Okay? So this fraction can never be equal to 0. Which means, if we fast forward to the graph, our graph will not cross the x-axis. Because if it did, our function, secant, would be equal to 0. So our graph will not cross over the x-axis. Okay. Love it. When is secant equal to 1? What has to be true? So what's got to be true? For this fraction, my black fraction here, to equal to 1, what has to be true? Cosine has to be 1. Okay? So where is cosine equal to 1? 0 into pi. Negative 2 pi, I'm guessing then? Anywhere else? Anywhere else? Nope, nowhere else. Okay. Put 0 or equal to 1. That's 2 pi or equal to 1. And that's negative 2 pi. Or equal to 1. Okay. When is secant equal to negative 1? What would cosine have to be? Cosine would have to be negative 1. Where is cosine equal to negative 1? Pi? Negative. When is secant undefined? Cosine is 0, yep. And where is cosine equal to 0? Pi over 2. 3 pi over 2. Negative pi over 2. And negative 3 pi over 2. And those are all going to be what again? Asymptotes. Vertical asymptotes. Yep. Ooh, missed. Okay. Now we said that it can't cross the x-axis, correct? So if it's not allowed to cross the x-axis, and I'm not allowed to cross a vertical asymptote, the only place that this one can go is up. The only place that the purple ones can go is down. And up. upper ones can only go up. Because I can't cross my blue dashed line, and I can't cross the x-axis. And that is the graph of secant on the interval negative 2 pi to positive 2 pi. Okay. What I would like you to all do now is I would like you all to graph cotangent and cosecant using the same methods. Okay? Same interval, all on the interval negative 2 pi to positive 2 pi. In person, what I would like you to do when you're done with them is I have the answer keys up here. You can come check them or ask questions of why yours differs. Okay? Online, people at home, I would like you to do these two, then turn your cameras on and just show them to me. And I should be able to see if you're off a little bit or not. So far it's only taken, this is my third pre-calc class of the day, and I think 5 or 6 people had to go fix one of the graphs. But otherwise everybody's been spot on today. Okay?